ARM microcontroller and embedded system module 5 topic which we'll be discussing is task communication. This belongs to a section of RTOS. So basically what is task communication? So communication happens to be exchanging, sharing information between processes. Over here, task communication happens to be sharing or exchanging information between task, or rather than task, people use a word process. If you're able to exchange some information from one process to another process, that's what we call it as task communication or process communication. So in multitasking system, so multiple tasks might run concurrently. When we talk about this concurrent, they run in parallel. Multiple tasks might run in parallel, and sometimes there might be a occasion wherein they may interact, or sometimes they may not interact. When we talk about saying they interact in the sense one process might depend on some other process. So based on this interaction, or based on the degree of interaction, the task communication could be categorized into cooperating process and competing process. In cooperating process, one process would depend on another process. A task, if it's been given, a application if it's given, then one process would do the task to some extent. After that, it would forward, or it would ping another process to complete the complete process. For example, right now we've been given the task to complete all the modules belonging to a course. One process, you can consider it as a faculty, would handle some sessions to complete a module part, and one more process, you can consider one more faculty will complete the remaining portion. So the complete portion is covered with the help of these two processes, and you call it as cooperating because they always share information, what section, who to carry out, that will be discussed. So it is kind of a cooperating process. Whereas in competing process, it's something like it's kind of situation, like you can treat it as an exam. You've been given with the task, and if there is a reward given if you complete the task in quick time, then literally you don't want the information to be shared. So independently the process will try to complete the task. Understood? So there is no relationship between two tasks, they work independently. Rather than in cooperating, there is always a dependency between the processes. In competing process, they compete for achieving some goal, for compete for some shared resources. Probably it could be a file, it could be also competing for the hardware like display device unit, so on. So we will just concentrate on the first one, that is cooperating process. We will concentrate because we are indeed supposed to communicate between processes. So this concept is also known as inter-process communication. Inter-process implies between the process there is a communication. So between the process, or you can call it as cooperation, the process can communicate through sharing, one method. Okay, so cooperating process could be further classified into cooperation through sharing. So in this case, you will have a kind of a resource, or you call this resource could be a memory, and this memory will be shared by the processes. How many processes you are using, they can share this memory, or could be a file, what it could be anything. So here, since both processes would work on the same memory or the file, there is a kind of a communication. Okay, they can communicate to some extent, not directly, indirectly it is. And one more is communication, or cooperative processing with the help of communication. So here there is a kind of a message. Suppose if process 1 needs to communicate with process 2, the process 1 will send a message with the help of an operating system kernel component, and this kernel component could forward that message to the process 2. This way, one process is going to you know interact with another process. Okay, this is a simple block diagram of the first concept, that is cooperation through sharing. So you have process 1, you have process 2, and there is a resource share data. So this is a memory region which needs to be shared between these two. So what basically here we can convey is that process 1 could use this memory region and it can alter if required, and the process 2 here would be used here just to reading the data which is there in this memory region. So memory access, memory modification could be done with the help of process 1, and process 2 could be used here to reading the information present in this memory region. Similarly, the second pictorial diagram shows the cooperation through communication. So here process 1, process 2, they do have a message. Suppose say that this M happens to be a message which needs to be passed to the process 2. Then first this message is passed through the kernel, and with the help of the kernel it is forwarded to process 2. So this way there is in this case there is nothing like a shared resource available. So with the help of this operating system, one process is going to communicate with another process. So as addressed, the concept is inter-process communication, or in short referred as IPC. So here the things related to shared memory, the information which we'll be talking about is global variable. This is one method, pipe method, and memory mapped objects. All these are features. So suppose if the process wants to communicate with the help of the shared concept, and this is using message passing concept. You have message queues, mailbox, and signals. So to begin with the shared memory concept, so let's talk about the global variable, not in detail. So global variables, we know in C program or C++ program, we might have come across variables declared outside the main function, could be used by the main function as well as the functions or modules which are included in the program, which means it is visible to all, visible to main function as well as the modules, if at all, if it's present, module or function rather. So that's about the variable, and this variable can be shared. It is visible, can be shared between the main program to function. It can be shared, but it is visible everywhere. You terminate the program, then only this information would be killed. And in the concept of pipe is we'll discuss what is pipe. So before beginning with shared memory concept, in simplest sense, we can say that you have a process 1 and you have a process 2, and this could be like, if we want to make this concept understand, we can take a real world example wherein if we want to transfer some information, useful information to the students. Assume that you're in an institute and you want to share some information to your students. Then what basically can be done is the higher authorities, probably a HOD, could use a notice board, and the important information could be addressed in this notice board, so that the students, whenever they are free, they can approach, they can have a look at what is happening, and thereby this information is shared between process 1 and process 2. Now over here the situation, the process 1 is made, this information is been written with the help of process 1, which means process 2 cannot write there. Notice board, we make a strict agreement that the process 1, because higher authorities only, they will be given the necessary privilege to write on the notice board. Students definitely will not be using it, and they can just read the message placed in it. So this is one example, real world example of shared memory. You consider shared memory as a notice board information which needs to be shared between two processes. So this is the concept in real world, whereas when we want to implement it in technological field, then we talk this concept as a pipe. Okay, so shared memory pipe concept. So pipe is similar to, it is a shared memory, wherein for a pipe concept you will be having a pipe server and you will be having a pipe client. So pipe server is the one which is going to create a pipe, or you can say that pipe server is a one which creates memory which can be shared by the second process, or the second process can use that memory. And pipe client is the one which has to be connected to this pipe server to gather the information. Okay, I repeat, a process which creates a pipe is known as pipe server, and the process which connects to the pipe is known as a pipe client. So you have a concept of pipe client and pipe process, and the implementation of this pipe is operating system dependent. So Windows platform, the way you design the pipe structure is different, and the way you design it in Linux operating system is different. And even in this you have anonymous pipe, and also you have named pipe. In anonymous pipe, it is unnamed unidirectional pipe, and named pipe, it can be bidirectional. Anonymous pipes can also be uh, literally it will be unidirectional. Anonymous implies they don't have name. Name pipe implies they do have a name. Okay, and here you can see this pictorial diagram. Process 1 is writing a information in this memory, and process 2 can read. So in one end there is write, and one more end you have read. So it is unidirectional. Suppose if you want to change this pipe into bidirectional, then at one end there should be a mode for writing as well as for reading. Similarly, at the second end, you should have a privilege read and write as well, so that you can say that the process one, it's not just meant to write. Process one can also read. Similarly, process 1 in this, process 2 in this case, it is meant to read. You can ensure that if the situation is bidirectional, then process 2 can also write. At the same time, it can also read. So that would make this bidirectional. The pipe will be looking kind of a bidirectional, having a bidirectional structure. This is about pipe. And the second concept is memory mapped objects. In memory mapped objects, the situation is you have a, let's talk with respect to this picture. You have a physical memory and you have a memory section. Let's say that if the diagram is clear, then you have this is actually the region belonging to your physical IC. You think this as a RAM, and this address has to be transferred to process 1 as well as process 2. So this is your shared region, this is your memory which needs to be shared by process 1 as well as process 2. And in this situation, we will think as if process 1 would use this memory for writing, and process 2 would use this memory for reading. Now to make this happen, that is to access all the information present in this region, so altogether can think 00000 to 8000 it goes. That's your complete space which could be accessed using process 1 and process 2. So here total number of bytes addresses, so size of the memory object, this is your memory object which needs to be shared between these two processes. And when you're using memory mapped object concept, so first step what you need to do is you need to for transferring onto this unit and along to this unit. So this process 1 and process 2 will be having virtual address. Okay, so first job what you need to do is map the physical memory what you have into the virtual memory space. Okay, so once that is done, then you can view the information present in this RAM only after you map. So for mapping, for creating the file mapping, you have a function named create file mapping. Okay, and this create file mapping has 6 arguments altogether. And the first argument is set to -1. -1 implies that you're supposed to create a file object, you're supposed to create a memory object. It's there here, to create a memory object from system paging memory, or to create a mapping. It's to create a mapping from system paging memory. For this, the first argument should be -1, and second argument is set to null. This is the structure of create file mapping. So all arguments are addressed. Also, its data type is addressed. So h file is -1, handle is -1, saying that you are supposed to create a mapping between virtual memory and your physical memory. And second argument is security, related to the process security attributes, and we don't provide or give any security feature, hence it is null. Third argument is about the file protection. Is it the data which you're going to access, is it in read mode or is it in write mode? So here we address it as read write. The page which we are accessing from the physical memory could be used for reading, as well as could be used for writing purpose. And the next, we have two arguments, the maximum size high and maximum size low. This is combined, this is 32-bit, and this again the 32-bit. So altogether 64-bit data, or using 64-bit representation, the memory object size would we have. For example, in this case, the memory object size is 8000. So 8000 is represented using 64-bit form. So in 64-bit, we break this into 32-bit high and 32-bit low. D word stands for 32-bit double word. Word is 16, because these terminologies are used for 8051 controller. Hence double word stands for 32-bit here. Okay, 32-bit higher 32-bit, lower 32-bit, which literally complete 64-bit addresses the size of your memory mapped object. And the last one is actually the process name, which is memory mapped object. That's the process name. Okay, so this case we set the information to this, so that's what is addressed here. So create file mapping -1 null page read write 0 8000 memory mapped object. So after creating a mapping, then to view the mapping, we define one more object, and this object in turn takes this created object. So this created object is HP1 file map. This argument, once if it's getting created, or once it gets created, this argument will be passed as a variable to this second function, which is a map view. Okay, so this has HP1 file map, and along with that, so altogether this has 1 2 3 4 5 5 arguments, and those arguments are addressed as follows. So h file, this is a mapping object. HP1 was a mapping object name, and have desired access, offset high, offset low, and number of bytes to map. So handle value is set to HP1 file map. This is the created object. Then desired access, since we want process 1 to use the memory to write, hence we write file map right there. Desired access field, it is to write, and offset high and offset low will be set to 0. When both are 0, it means that you can start accessing the physical memory from the beginning. Okay, for the memory mapped object could be accessed from the beginning if you set the value dw file offset high and dw offset low to 0. Okay, this is just for indication. If you want to access all the information present in the physical object starting from the beginning, this should set these two components should be set to 0, and the final component, if it is made 0, then the whole memory mapped object is owned to the process. The whole information, not from the beginning, the whole object is made visible to process 1 and process 2. You, rather than saying available, you call it as they are committed to memory mapped object is committed to process 1 and process 2, so it can access. Okay, so that's what you have. This explanation is given, and you can see only one information here. This is, since it is able to write, you have file map write for process 1. So this mode, you can figure out what's happening here, but you cannot change any data here. Both processes, this information is visible. One can write, another can just read. So you can view the information present here, but you cannot alter in process 2. Okay, so that's about the concept of memory mapped object. Beginning with the next one. Now it's not related to resource sharing. We will be using message passing. In message passing, there are methods like message, message mailbox, message queue. Okay, the first method of message passing is message queue. So message queue, why would we require message passing? Message passing is required because previous case we have seen a scenario wherein the size of the shared memory might be huge, but literally if you want to communicate with one process with another process, small information, if it needs to be passed, so you can think as if it's a message. So for such application where small amount of information is passed from one process to another process, then literally you can use this concept. Message passing concept could be used. Okay, and it would be faster. You do not have too much burden for creating an object, viewing an object. So many overheads could be removed. So if you are using this concept. Fine. So the first topic in message passing is message queues. In message queue, the queue implies first in, first out. So here you have a queue system. Queue system means definitely there will be a memory reserved, and this messages, whatever a message you want to pass from process 1 to process 2 will sit in the queue. You want to pass 100 messages, so all those 100 messages will be placed in this queue temporarily, and whenever after that, once the queue is filled, probably one message at a time can be passed to the process 2. Okay, and here we use the messages, two methods we use: send and receive. Send implies, in send we specify the name of the process to which the message is to be sent. For example, send method from process 1 to process 2, this message has to be sent to process 2. So you'll indicate the process 2 name here, saying that the process 2 is actually the destination, so that will be mentioned in send method. In receive method, the name of the process from which the message is to be received. So since for the method receive, you will be receiving the message from process 1, so process 1 should be highlighted in receive method. Okay, so this way you exchange the information between process 1 to process 2, and again the methods, send and receive methods, are operating system dependent. For different operating system it would be completely different. The next concept which we have is mailbox. The difference between mailbox and mail message queues are this doesn't store anything, and literally if you want more messages to be passed from one process to another process, then you will be using message queue, because since you have a queue structure developed, more number of messages could be stored in that queue temporarily, then it could be forwarded to the destination. Whereas in mailbox, you don't have kind of temporary storage memory reserved here, which means one single message is exchanged. One message is exchanged, and here the exchange mechanism, what we look at is it is broadcasting. That is the information which needs to be passed from the source to destination. You can consider task 1 as the source, and assume that 3 destinations you have: task 2, task 3, and task 4. This is your process 1, this is your process 2, process 3, and process 4. One information should be broadcasted to the uh, processes 2, 3, and 4 respectively. So place it in the mailbox so it could be delivered. And if you want to make this feature available, the clients who uses this mailbox service needs to subscribe uh, to make this service available. Okay, so one difference is one message at a time could be exchanged. That is the disadvantage. Multiple messages cannot be you know forwarded from one unit to another unit. So that's about the mailbox. The last one is the signaling method. So you can treat signaling as you can consider it as a software interrupt. So what is software interrupt and hardware interrupt? Software interrupt would it will trigger your normal execution of program. Whenever your program runs normally, you won't be having any problem. But if there are some exceptions, for example, say that you're running a program and there is a concept of divide by zero. So in such case, the program will give a exception to the compiler, saying that you cannot run this application because there is an issue. It is an exception because for different inputs, some inputs it might work, some inputs it will not work. Okay, so this exception can be handled. So each exception whichever is going to excite your process is having a service routine provided. For example, in your microcontroller, ARM controller, there are totally 256 exceptions and interrupts, and every hardware or software exception or interrupts are having its own service routine addressed for each of the exceptions or interrupts. You have its available service routine wherein you write what basically measures you need to take to handle this exception or interrupt. So that's kind of a software interrupt itself. And we don't know, we cannot it is not predictable when this exception happens, since you call it as a asynchronous event. Okay, and in some of the operating system like VX works, we this kind of a signals are used. Okay, and yeah, that's what you have. Hope the concept is clear. Signal, okay, it's like it is also information to pass from one process to another process. One more example which we can consider here is say that process 1 has to interrupt, or process 1 has to interact with process 2 so it can pass the signal, and say that for this particular signal there should be a signal handler present in process 2, and the process 2 can handle it accordingly. So which means the process which signals which is meant to drive another process, the another process you are supposed to write the service routine for the signal, what it has to do upon getting a signal from another process. Okay, this way the communication be can be made happen. Okay, time being we will wind up.